Good evening to all my listeners. This is Devin Prashad taking on another lecture on the C programming series. Today we will discuss about a new concept which is known as recursion. What is the meaning of the recursion? Is the phenomena of the programming world or from or is coming from some other world? This is the one idea that we will be discussing. Second, how we are going to deal with the recursion in the C program, and third thing, why we are using the recursion, and can we write a few programs using the concept of the recursion, and how we are writing those programs, and basically what is the concept behind the recursion. Okay, so let's start. For your uh, uh, help, I have written the definition of the recursion here already. So if a function calls itself with a different arguments in each call, it is not all, it should be call. In each call, oblique invocation to achieve some task, this phenomena is known as recursion. So what does it mean? Earlier we have studied about the function. So there will be a function, let's say function, this is the name of the function. There is no argument, there is no return value, and there is some body of the function. And obviously we will call this function at some point from this main function. So this will be the call, and then this function will be returning some value at this point again to the main function. So this is how we actually do with the programming in the or using the functions. But one thing we notice here, that the function is a separate entity or separate body, and we are calling it from a different entity or different body. So we can call it, this is my module 1, and we can call it, this is my module 2, just for the sake of the clarity. And in this scenario you see that we are calling this function from the main function, and this function is returning to the caller, that is again the main function. So such kind of mechanism we see. So in this scenario we say that the function is called from the another function, that is main function. But there may be a scenario in which once the function is invoked by the another function, but after that that function is calling itself for a number of times, and in each call or in each invocation it is having the different number of arguments to deal with this function. So in that sense we call that there is a recursion. In that sense we call that there is a recursion. So in terms of function, we can easily understand the concept of function with this phenomena, that if a function calls itself with different arguments in each call or invocation, then we have recursion. Okay, and now let us understand what is the concept behind the recursion, or how the compiler is going to implement this recursion concept using the function. So simple thing, we know that there will be an stack. This is my stack. Stack is something, some memory area where only the last in first out kind of mechanism is allowed. For example, whatever element is coming to this stack, this is the first element which is coming to this stack, and this will be the second element, and similarly this will be the third element. So whatever element which was inserted last, the C was inserted last, so will be the first element to be deleted first. So last in first out, whatever element is coming at last in this stack will be the first element to be deleted from the stack. So this kind of mechanism is maintained. So where we are maintaining such thing or such concept, so that we that thing is known as stack. So recursion is always using the stack. So what is the concept behind the recursion? That recursion is using the stack, and for the first invocation, for the first invocation, something is recorded in the stack, and then from this first invocation, the second invocation is happened, that will be recorded in the stack in this manner, and from the second invocation, the third invocation will happen, so that is also recorded in the stack. And in this way, we are storing the invocations each time, or whatever number of times the function is invoked by itself, so we are storing that thing into the stack. And at last there will be something to stop that call pattern, and that call pattern will be returned by something, some constant value that will be returned at last. So at that moment we will stop this call pattern, and after that, once this call pattern has been stopped and we are getting some return value for the last invocation, so that return pattern will be used, or you can say that return pattern will be traversed in this reverse direction to generate the actual value. And finally, with that return pattern, we are getting the final value here at the last in this stack, and that we will return to the caller function. Okay, so this kind of mechanism is actually maintained whenever recursion is happening. So that who is the component which is maintaining this concept? So that is simply the compiler. Okay, so lots of technicalities is there, so it will be clear with an example. So let's begin with an example to understand the whole concept. So for example, we have a problem, and in that problem we want to print sum of numbers between 10 to 1. As we know that from the 10 to the 1 there will be these many numbers. There will be 10, 9, then 8, then 7, then 6, then your 5, 4, 3, 2 and 1. And you see that if we want to add all these 10 numbers using the concept of recursion, so what is the thing? We know only this thing first. Then what we will do? We will add this 9 to this thing, and we will store the result of these two, 10 plus 9, into this stack like that. Okay, and for the next time we will add 8 plus, let's say, some 7. In this way we are going to maintain a stack, and at last we will be getting some final value, and then we will be returning back. Okay, so the concept we are going to do this. So first let's see that how we are writing a simple function for it. If we want to write a function where recursion is supported, so we simply first write that function to add all these 10 numbers, and then we will see how the particular code is working on. So then you will be able to understand the concept of this recursion. So let me erase this unwanted thing first, so that I will be getting a bigger space where I will be explaining the thing. And meanwhile, if you have idea that how we can write a function for doing this thing, so you can use that function prototype information or function prototype knowledge to write a particular function. That exercise we have done in the previous lecture, so the same concept you have to apply this time. So let me clarify the thing. So the very simple thing that you have to do is you say that the name of the function is sum. M, only one argument is given to this, and that argument is integer, so I am calling this single argument as n. Obviously this function will be returning some integer value, so return type will be int. Now inside the recursion there must be always a stopping criteria. Stopping criteria, if it is there, then only the recursion is going to be stopped, otherwise it will continue and nothing will happen. So how you are going to stop the recursion, or what is the stopping criteria for this? So as per this problem, so first we will add some variable, let's say sum is equals to sum plus 9. Then next time we will be adding sum plus 10. So 10 has been added. So next time we will be adding sum is equals to sum plus 9, and so on and so forth. But how we or how many times we carry out such additions till we are getting the last one. So once we are getting this one, then we have to stop. So that is my stopping criteria. So I am writing that stopping criteria first. So how I am writing that, if my n will become exact equals to 1, then I have to return that value 1. Else what I have to do, I'll simply use this statement, return n, that is the number, plus next time I want to add sum n minus 1. So that will be my simple statement. So this is my simple function which is actually using the recursion. Okay, obviously this function will be invoked for the first time from the main function. So I am writing the main function just above of it. So where I am declaring an integer value, let's say a, and putting 10 into this, then I'll call this sum function and pass this a to this sum function. So whatever sum will return, the first call will be invoked from this place, and whatever value at last will be returned, that I want to store in some another variable. So let me declare another variable val. So I'll store that value into the val variable. So after that I'll just printf %d, val is just a number, so I am going to print this val. That's it, and I'll close this main function. So this will be my complete program using a recursion, where a function is implementing the recursion concept to add all the 10 numbers. And we know that all these 10 numbers are in successive pattern, means 10, 9, 8, 7, 6. And the idea is, first I'll pick up 10, I'll add it with the 9. Then whatever sum I am getting, I'll add that thing with the 8, and so on so forth. Okay. So first time this sum will be invoked from the main, and it is getting 10 here. Now 10 will be tested here, it is not equal to 1, so it will come to this place, and it will return what, 10 plus sum 10 minus 1, 9. So in this statement 10 is the value, but sum 9 is again a call. So again it will call this function, and this time it will call this function for the value 9, and so on so forth. It will continue till the n becomes 1. Okay, and if you run this program n equals to 10 and wants to see how the program is running itself, so as I told you in the beginning, a stack is going to be maintained. So first stack is going to be maintained. So for the first time only the invocation is for the sum 10. So this invocation is going to be stored in this stack. This sum 10 will be tested here, 10 is coming here, and you are returning this thing. So whenever this sum is invoked, so you are returning another value, 10 plus sum 9. So this 10 plus sum 9 will be kept at this place in this state. Now in this, you know that sum 9 is again a call. So next time this will become what, 9 plus sum 8. Then another time it will become 8 plus sum 7. Then it will continue like this, 6, 7 plus sum 6. Then 6 plus sum 5. Then 5 plus sum 4. Then 4 plus sum 3. Then 3 plus sum 2, and lastly this is going to be repeat itself for for this is 2, so 2 plus some 1, and this 1, when the value of n will become 1, this will be tested here and it will come here and this is going to return 1. So the last call is going to return an integer value 1. So at this point there is no further invocation of the function and you are getting the actual or final value return, that is 1. Okay, so this is what call sequence. So this is known as call sequence and this is going to be stored in a stack area. So a stack area is going to be used. Then once the call sequence is stopped, a return sequence is started. So how the return sequence is started? So this was the one that is going to be returned to this call, and this someone will get erased like this and it will be replaced by this value 1, and now this value become 3. Now whatever value is generated at this position will be returned back to its call, and its call is sum2. So this sum2 is going to be erased like this and it will be the value which is returned will be placed here and this will become 6. Now this 6 will be written here and whatever value will be generated here it will get written here, and so on so forth. In this sequence the things are coming at this last invocation, and this last invocation will get erased as I had done this exercise earlier. So the last value will get erased by a value which is coming from the just its previous invocation, and that value will be 55. So I have tested that program and you are getting that value as 55 here, and finally that 55 value will get returned to the main callee. So this 55 is going to be returned to this main function, and this val is going to store that final value because of this statement, and this after receiving that value into the val variable it is going to print that thing. Okay, so this is how the big concept of the recursion is going to be used. Okay, although it is very complex, but there are certain situations where the recursion is going to be very helpful. Again, at this moment you please remember that wherever you do the same thing by using the iteration means by using a for loop, whatever you can do, like for example you this sum can also be performed by using a for loop as well. For example, again there are 10 numbers 10 to 1, so you are just using a for loop, starting this initializing this I to the 10, then you are putting the condition I greater than equals to 1, and then I minus that should be decremented, and inside this you have created a sum variable and you are writing simply sum is equals to sum plus I. So what will happen? Simple, it is summing all the 10 numbers between 1 to 1 and finally value you are getting the sum, and that sum is again contain the 55. But here the same problem has been solved by using the iteration means loop. By using some loop or iteration you have solved the same problem, and the similar problem you have solved using the recursion as well. Now what is the advantage of using this one or this one? In some situations iterations are very fast because you have flexibility, there is no extra space or stack is maintained. But in the recursion if you are going to do the same thing, a stack is going to be maintained, means some extra memory is required. So it is costly solution, it is easy solution or less costly solution, but there are certain situations where such iterations are not possible. So in those cases only the recursion is applied. So two things please remember regarding the recursion, that wherever some recursive pattern you see, recursive pattern means whatever the current value can be obtained by adding, multiplying or dividing the previous value, and that previous value can be obtained and multiplied by can be obtained by multiplying, adding, summing, whatever operation by its previous value. If such pattern you see, and obviously in that pattern there will be some stopping criteria as well, so in those situations you can apply the recursion. Okay, the same program like factorial program can also be implemented using the recursion. So how you are going to use or implement the factorial program using recursion? So first, think about the factorial. So what is the meaning of the factorial? If I have given to you a number 5, so how you are going to calculate the factorial 5? So factorial 5 is nothing but 5 into 4 into 3 into 2 into 1, and here you see that the first the first is going to be multiplied to its previous value, and this 4 is going to be multiplied to its previous value, and so on and so forth till 1. So 1 is the stopping criteria. So again, if you have prepared or created that sum program, so you can easily write this factorial program as well. So again, so there will be a factorial, so I'm writing fact, it is getting a number, let's say I'm taking that number in argument n, and obviously it will be returning an integer value. We go inside. So what is the stopping criteria? If n exact equals to 1, then I have to return what? 1, because if n will become 1 and we do not want to proceed beyond that, so we will return this 1 as it is. Else we have something to return, and what is that return? N return n into fact n minus 1. That's it. This is your factorial function. Now you are writing your main function. Inside the main function you are declaring an integer value int n, or let's say some value a, putting 5 into this, and a variable val. Then you are calling your factorial function val equals to fact, and you are passing this a. The first call will be from this place, and after that successive call will be made from this place with the different values of n. Okay, and once you are getting the final value into the val, you are going to print this value, printf %d val, and closing this main function. So how easy is to write this recursion program? Okay, so once you have got the idea that for any recursion program, first of all you please notice that there is a repetitive pattern, and if the repetition pattern is there, so the problem is going to be solved by using either the iteration or the recursion. If it can be solved by using the iteration, means using some loop, for loop, while loop, do while loop, whatever loop you want to prefer, if you are able to implement that logic using the iteration, so it will be very easy solution, very cheap solution. Okay, and it is always preferred. But the same solution you can obtain by using the concept of recursion as well. And for the recursion you have to put the piece of code into the function, and then you have to implement the mechanism of calling the function by itself. And please remember, definitely there will be some stopping criteria. So at this stopping criteria you definitely will return some value, and whenever and for the other part you will be returning some repetitive pattern mechanism. Like in the case of factorial you are returning n into fact n minus 1. In the case of sum you are returning n plus sum n minus 1. Okay, so these are the two programs which are based on the recursion, and these are the very common program or very important program which are always asked in the university examinations or in the competitive examinations as well. But with these two programs we must understand that what is the logic behind it, what is actually happen behind the recursion concept. Okay, so definitely there is a stack is going to be maintained, every invocation is going to be recorded in that stack, and once you are getting the final return value, then the return sequence carried out, and once the return sequence is over, then you are getting your final value. So extra maintenance of stack area is going to be maintained, so there is always an extra cost. Okay, so once you have understood the idea, the concept, and then we can verify those concepts whether these are actually working or not with the our famous procedure that we always uh, verify the logic by writing the program into the turbo C++ compiler. So I'll open a new editor. I am getting something, so I'm going to use it. Otherwise you will be getting a blank screen and you have to type all these three things from the scratch. Okay, so the very first thing you have to do is save your file with the .c extension and recur1.c. I'm going to name this file as recur1.c. Okay, so first line I am writing include stdio.h, second line I'll write conio.h, then your main function, and this is the structure that we generally use. I'll be using two markers, CLR, SCR. This will be the first marker, and between this I am going to put the logic, and before the CLR SCR I am going to declare the variables. Okay, but my idea is first I'll write that function that is implementing the recursion logic. So the first program I'm going to write the sum of all these numbers. Suppose I'll provide 10, so sum of the numbers between 10 to 1. If I'll provide 50, the sum of numbers between 50 to 1. Okay, so the syntax is what? It is returning an integer value. Its name is sum. It is getting an integer argument, only integer argument n. Then inside the body you are going to write the logic. If n exact equals to 1, then you are going to return the value 1 and your recursion will stop. Else you will successively call, you will write this statement return n plus sum, and this time sum minus 1, n minus 1. Okay, so successively you are calling your function, and this is the thing, this is the invocation is going to be recorded into the stack area. So in this stack area you are going to put these things: n plus n minus 1, n plus sum n minus 1. So first time 10 plus sum 9, second time 9 plus sum 8, and so on and so forth. Okay, so only thing you have to do, you have to declare a variable int a, put some value, let's say 10 into it, then also declare a variable val where you are going to store the final value. Then after this CLR SCR you are going to call your function for the first time like this. So first invocation will be from this place, and after that the successive invocations will be from this place, means the function is calling itself. So this is recursion, this is nothing but recursion. So finally the recursion is over, you are getting the value into the val variable, and that you want to print the final value is your %d and then the val variable. Okay, so let's verify, is there any syntactical mistake or silly mistake I have made? So I think no. So I'll just save this program, I'll run this program, and you see that you are getting the final value as 55. So nothing is wrong in that code, so you are getting the 55 as I told you earlier. Okay, so let's modify the same program for the factorial. So again we can go for a new window, we can zoom it with the F5 key, we can save it with the .c extension, this time recur to .c. There is already an existing file, let me overwrite that file. So the first line I am writing include stdio.h, second line this is include conio.h, then your main function, and in the main function there will be two markers, that is CLR SCR, and then your getch, and then I am creating that function. It is returning an integer, its name is fact, it is getting only single argument int n. Then inside this the very simple code you have to implement is stopping criteria. If n exact equals to 1, then you have to return a value, return value that is 1. Else you have to recur. Recur means return n into fact n minus 1. So using a stack you are going to recur. So that is the simple thing. Here you will declare an integer variable a, putting, let's say I want to calculate the factorial of 5, and then there will be a val variable, and I am calling this function like this, fact fact, and then passing this value a to this, and after getting the entire value into the val variable I am going to print it, printf slash n, the final the factorial value is percent %d, and then your val variable. Okay, so let me quickly check whether there is any syntactical mistake, and I think there is no. Save it, run it. So the factorial of 5 you are getting is 120. Okay, so I hope you will be getting the concept with this simple explanation. The first thing you have to repeat that what is the meaning of the recursion, and what is the concept maintained for implementing the recursion by the compiler. There is a stack is going to be maintained. If uh, the other alternative for implementing the same problem is also available, means using some iteration or using some loop, but that will be a cheap solution. And if you are implementing the same thing using the recursion, so you have to bear the extra cost of stack maintenance. Okay, but anyway, the stack maintenance is going to help you to implement the recursion logic. Okay, so thank you guys, thank you for listening me patiently for today's discussion. So this is the next portion, next topic after the function, and with this the function concept is going to be over, and tomorrow we will discuss with a new concept that will be the pointer. Okay, so till then, bye bye, we will meet in the next lecture soon. Thank you so much.